Hey, good morning. So welcome back to college algebra, and we are going to finish our discussion on quadratics and parabolas here. Same thing. These are a couple of application problems, and this is very typical of what you're learning this for, is because in other classes, this is the kind of problem you're going to be confronted with. All right. So actually, number 12 is pretty typical. Number 13, we'll talk about the other ones when we get there. All right. So we have a gas mileage of a certain vehicle can be approximated by, okay? And it's always important to know, to write down your variables and figure out what you're talking about. So, when you're working on something like this, right, we'll say m of x, right, is equal to negative 0.028x squared plus 2.672. Let's put that decimal point in there. X minus 35.02. All right, here we go, 35.02. Now, x is equal to the speed of the car in miles per hour, and m of x, right, that's the gas mileage. In miles per gallon. Okay, so it's always important to have an idea of this. So when you do start problems that are word problems, if you're the person writing the formula, let people know, like, what are my variables? And a lot of times I'll do it this way: x is equal to speed, and I'll put a little miles per hour here, right, or miles over hour, and then m of x, right, this is gas mileage. And this is miles per gallon. All right. So when we're getting into this and they start asking the questions about different things, right? It's always nice to go back and refer to, like, well, what are they asking? What are my answers going to be looking like? All right. So part 1-2, right? It says determine the speed at which the car gets the maximum gas mileage. Why do they ask about a maximum? Well, excuse me. Look at the parabola, right? The leading term is negative. Which means, sorry about that for the people with headphones, which means it's a parabola that opens down. There's going to be a maximum, okay? So if I just, think about what this is going to look like without regards to a scale or to a coordinate axis, right? We're going to have something like that, all right? So why don't we go ahead and, figure out the maximum. That's going to be where the vertex is, right? And again, we could use complete the square on this. I would highly recommend against that method. Okay, I would use the vertex formula and I'd say, well, maximum happens when x is equal to negative b over 2a. Right? So what do we have for negative b over 2a? We have this is 2.672 divided by twice, and then we have negative 0.028. Okay, so put this negative in here because of this negative, b, and then 2a. We have two negative signs, right? So we're going to cancel those out. This is going to be a positive value. Okay, so x is equal to 2.672 divided by it's 28. It's going to give us 0.056, I believe. 0.056. So I'm not going to pretend that I could do that arithmetic in my head. All right, it's not even close, right? We wouldn't bother. 672, okay, divided by, do this for a minute here, 0.056. Actually, we'll say, I won't even trust myself. I'll say 2 times, right? Use parentheses, 0.026, 28 rather. All right. What did I do? 2.672 divided by 2 times 0.028. All right, I probably put an extra parenthesis in there. Right, x is equal to 47.7. Right. So what's going on here? Right. It says round your answer to the nearest mile. All right. So 48. That's the nearest mile. Okay, the nearest mile per hour. So 48 miles per hour. All right. And it's nice to give us a little check. Right. And now we move on to the next part. Determine the maximum gas mileage. So all they're asking us is like, well, what's the X value for the vortex? And then what's going to be the mileage there? What's the Y value for the vortex? They're just asking us in a context that's a real world. So I would plug in 48 here. Okay, so let's see, we have, do I have a problem? Let's see. Oh, there we go, look at that. Okay, so we would put in, right, we put in mileage is equal to negative 0.028 times 48 squared plus 2.672 times 48. By the way, Popular Mechanics, I think, does a problem like this. They do an article like this for every year to talk about what the maximum mileage, what the best mileage is for what speed. It is nearly always in this kind of a range. Okay, so the people they're like, I'm going to do 70, so I get to the gas station faster. I won't run out of gas. Like that's not gonna help. All right. Let's see here. So we're going to type this in. Say negative 0.028 times 48 squared, okay, plus 2.672, and this is the kind of problem that you're gonna see. I mean, this is very indicative when you have, like, you know, more, or I should say more. This is very representative of problems in you know, real life type of things, right? 28.724, 28.724, and I have a feeling they're going to tell me round this, right? They maybe round this one to 0 decimal places. So, oh, 1 decimal place, very good. So 1 decimal place is going to be 28.7. Okay, so we have 28.7 miles per gallon. Right, and there we go. I think the previous one is very much like this. Okay, so this is, you know, 10 and 11, or 11 and 12 rather. Yeah, very similar kind of problems, right? We use the vertex formula to find the vertex, and then we answer the question to figure out, like, they usually want the X part and the Y part, and they're going to ask you in the context of the question, and we can just go from there. All right, next problem. The difference of two numbers is 8. What two numbers will minimize this product? Now, in a face-to-face class, I almost never ask a problem like this for a couple of reasons. One is the applications of this are pretty much limited to math class. And two, I went through classes where they would have a lot of questions like this, and frankly, they traumatized me. As I remember being, you know, 9th grade or something like that, and you know, between this and train problems, like that's it, we're done. All right, so the difference of two numbers, x minus y equals 8. That's the difference of two numbers, right? We subtract them. Which numbers will minimize the product? So what we're going to say is, you know, find a is equal to x times y, and I'm going to be expecting a right, a parabola that is going to be facing up, right? I'm expecting something like that. So we have a constraint and we have a problem. Okay, so this is my constraint here, and this is what we're trying. This is our, what they will call objective function. Later on, you'll be getting things like that. And the whole point of being able to do this is you have two equations, right? And then you have an x and a y. So the whole thing here is we can cast one variable in terms of another, right? If I added y to both sides here, right? We would say, well, this is x is equal to 8 plus y, but we also know that area or the, their product is equal to x times y. So this is x, and what we could do here, right, instead of x times y, we could say this is going to be 8 plus y times y, all right? So we have 8 times y, or 8 plus y times y, and that's going to be 8y plus y squared. Okay, so hey, this looks a lot like a parabola. It opens up, so I'm pretty happy about the fact that it's matching my expectation. And again, where is this going to be? That's not 8y squared. Okay, it's plus. Where is this going to be? Where is this thing going to be minimized? I need the vertex, right? So the vertex, right, is y equals, right, negative b over 2a, right? A is my function value, right? A is functioning as y usually is, but y is now functioning as what x usually is. We go ahead and say, okay, well, that's going to be negative 8, right, minus b over 2a. So negative 8 over 2 is going to give us negative 4. Okay. So let's see here. We know the vertex is negative 4. What is that area? We can just type it into this, right? We can say 8 minus 4, right? 8 plus negative 4 times negative 4. So that's going to give me that times negative 4. We ended up with negative 16, all right? So y is equal, or this whole thing is equal to negative 16. They might want to know what x is, okay? So because we know x plus y, so we have x is equal to x, or 8 plus y. So x would be 8 plus negative 4. 8 minus 4 is 4. Okay. And again, we multiply them together, we still get negative 16. So my solution here, right, is x is equal to 4, y is equal to negative 4, and then we'll see what happens here. All right. Let's see here. The numbers are, okay, negative 4 and, no, 4. They didn't ask me what the, well, not yet, they didn't. Oh, one of these should be negative. Thank you. Oh, they didn't want any more. Okay, very good. Yeah, that's going to tell me, hey, you don't have to put the positive sign there. Like, yeah, I know. All right, that to be a negative sign. All right, again, this is a very standard type of a problem here. It says 2 chicken coops are to be used or to be built adjacent to one another from 144 feet of fencing. All right. What dimensions will be used to maximize the area of an individual coop? All right, and they even gave us a little drawing here, right? They said y is this little piece and x is that piece there. So let's go ahead and draw this. Right? Always with a word problem, it's always good to draw first, even though they handed us a thing, but we're going to mark this up a bit. So we have a y, we have an x, and what we want to do is we want to say, well, x has to be equal to xy, or a is equal to xy. We're trying to maximize a, right? So we wish to figure out where the maximum of a is, right? Again, this is our objective function. And then what's our constraint? Well, we have 144 feet of fencing. All right. So the way this is listed out, right? Let's just count up how many variables we have. We have 1, 2, 3 x's. And then for y's, right, we have 1, 2, 3, 4 y's. All right. So our perimeter statement, right, the fencing statement, it's got to be 3x plus 4y, and that is equal to 144. Right. So, and just like the last problem, all right, just like the last problem where we have a is equal to x times y, but we have 3x plus 4y is equal to 144. So the idea here is we're going to solve for one variable and plug it into the other equation here. All right. So why don't we just do it this way? We'll say 4y is equal to 144 minus 3x, right? Let's put this to the other side. And then what we're going to do is we're just going to divide by 4 here. All right. So y is equal to 144 over 4 minus 3/4 x. I think 144 over 4 is a easy problem, right? It's excuse me, it's going to be like 9 or something. No, it's going to be 18. 144 divided by 4. 36. All right, off by factor 2. Y is equal to 36. I'm sorry, minus 3/4 x. Right? If you wanted to change that to a decimal, then that's fine. So my a, right? My area for my chicken coop here is going to be x times what's y? Y is 36 minus 3/4 x. Right. So if I go ahead and run that through, right, distribute, we have 36x minus 3/4 x squared. Right. That is equal to my area. Now this, right, this is a parabola. All right. And pretend it's a parabola. Right. And then what they're asking us to do, right, is figure out what the vertex is. This is a, and this is x. All right. So where is my maximum? It's at the vertex. So it's where x is equal to negative b over 2a. So it's going to be negative 36, right? Negative b is 36 over 2 times 3/4. Right? What's 2 times 3/4? That's going to be 6/4, which is 3/2. So we have negative 36 over 3/2. And again, do you remember like going back to doing a fraction over a fraction? This is negative 36 divided by 3/2. That's what this says. Okay. And if you remember what to do with division with fractions, right? That's negative 36 times 2/3. Right? It's going to be negative 24. Or, right, here's your bar, right? Here's your heavy bar. So we're going to have negative 36 over 1, right, over 3/2. Multiply top and bottom by 2/3. That cancels all of that out, and then we still have 36 over 2/3, 36 times 2/3. Okay, that's going to be what? 3 into 36 gives like 12 times. 12 times 2 is negative. There's negative b over 2a. This is negative down here. What am I doing? It's negative down here. So negative times negative makes it a positive. So my x value, right? 36 divided by, or times 2/3. That should be a negative. That's equal to my x value. All right. Either way. Okay. So now that I know that x is equal to 24, right? We can go back and figure out, well, y should be, right? Y should be 36 minus 3/4 x. Right? So 36 minus 3/4 of 24. Right? So 24 divided by 4 is right, it's 6, and then 6 times 3 is 18. So 36 minus 18, I believe, is 18. Okay, we could type it in. That's okay. Right? If you want to do it this way and say, well, it's 36 minus, right, 3 divided by 4 times 24. Right? We're good. So my y value, right, 18. X value was 24. This is all in inches, right? This is going back up to my original chicken coop here. It says we have, oh no, it's feet. Okay. So my x value was 24 feet, and my y value is oh no, it's 24 and 18 feet. Right. So if we wanted to go back up here, right, say this is 18, and this guy here is 24. Right. And that's our solution to this thing. So let's go ahead and deal with the problem. So what dimensions should it be? Oh, they are going to ask us too. Right, they wanted to say, oh, 18 by 24. I'm wondering if there's a particular order I should put them in. I guess I'll find out. All right, I don't think they cared. And then at maximum order of the chicken coop is we're just going to multiply those together. Okay, I don't know what that's going to be. So 18 times 24. 432. All right. And then that is how you solve those kinds of problems. All right. I know that there's one that makes you fold up the sides and multiply by the volume. And the way we're going to do that is the same way. Okay. So we're just going to type in our volume equation, right? Length times height. And then we're going to have like the length has to be. And then like one of these is going to be, one of these, or it's going to be a width is some kind of a function of h, and then that's going to be like 24, 30, or whatever it's going to be. This will just be constant, and then we'll just deal with a parabola with these two. But that's all we do. Okay, so hopefully that gives you some inspiration to finish the section's homework. They're not so bad, but you have to be a little bit careful with some of these. And 12, right? Problem number 12 with the gas mileage. And problem number 14, like when I go to rate my quiz, those are the two problems that I'm going to pick, right? I like 11, I like 12, I like 14. 13, not so much, all right? And that's what we have. All right, so to finish your homework with this one, and I will see you in the next section. All right, very good.